Welcome to today's tutorial on the serialization proxy pattern in Java. My name is Your Name, and I'm excited to guide you through this important design pattern, especially focusing on how to debug it effectively. First, let's understand what the serialization proxy pattern is. Simply put, it's a design pattern that allows you to customize the serialization mechanism of a class by using a separate proxy class. This pattern can help maintain the encapsulation and allows you to manage changes in your class's structure over time. Now, let me show you a basic example of a class without using the serialization proxy pattern. In this user class, the username and password fields are serialized directly. This can be a problem because if you change the internal representation of user later, it could break deserialization. So, how can we implement the serialization proxy pattern to avoid this? Let's create a proxy for our user class. In the user proxy, we only store the username and remove the password from the serialized object. This safeguards the sensitive data while allowing us to control the deserialization process. Next, let's modify the user class to use the serialization proxy. We'll do this by overriding the write replace and read resolve methods. What we just did. When an instance of user is serialized, it gets replaced with a user proxy. During deserialization, we convert the user proxy back to a user instance. This is crucial for maintaining control over our class's state. Now that we have our implementation, let's write a simple main method to demonstrate this pattern in action. This is a great start. You can see how easy it is to control serialization and deserialization. However, debugging this pattern can be tricky. Let's explore some common pitfalls. First, ensure that your proxy class is properly handling all necessary fields. If you miss a field during serialization, you will likely encounter null pointer exceptions or lost data during deserialization. Another pitfall is to make sure that the methods used to convert the proxy back to the original object are correctly implemented. Failing to do so can lead to objects being in an inconsistent state. Next, it's vital to override the hash code and equals methods in both your original class and the proxy. This will ensure that comparison operations behave as expected, particularly when dealing with collections. When debugging any serialization-related code, always log the state of your objects. Check if the data is being serialized correctly and that the proxy is providing the expected output. Let's simulate an error scenario. Imagine that we forget to include the password check in our user constructor for our proxy conversion. This will lead to a mismatch between serialized and deserialized object expectations. Now let's run our main method and observe the output. You might encounter unexpected behavior because the password is crucial for any further operations like authentication. To easily debug issues like this, you can use the Java debugger within your IDE. Set breakpoints where you're serializing and deserializing data. Step through your code to see the state of each variable. Additionally, consider writing unit tests for your serialization logic. Testing both serialization and deserialization within your tests can help catch issues early on. As we wrap up our tutorial, let's review. We learned how to implement the serialization proxy pattern, discussed common pitfalls, explored debugging strategies, and the importance of logging and unit testing. If you find yourself facing challenges with serialization in your projects, remember that the serialization proxy pattern is a robust solution worth mastering. Thank you for watching. If you found this video helpful, make sure to like, share, and subscribe for more Java programming tutorials. Leave your comments and questions below, and happy coding!